Okay, so to simplify a monomial expression, each variable base appears exactly once. That means if I have a squared and a cubed, I should have combined them into a to the fifth. There are no powers of powers. We should have done all the multiplication and brought those down. And all fractions are in simplest form. So those are our rules for monomial expressions. Let's turn over and take a look at our examples. Determine whether each expression is a monomial. So for the first one, we have 17 minus c. No, it's not because we have subtraction. Monomials, we are only multiplying, so you shouldn't be subtracting or adding in them. B, 8f squared g. Yes. All of those are being multiplied together, variables, and a constant, so that's okay. 3/4. Yes, it's a constant. It's fine. And the last one, 5 over t. No, we don't do it if there's a variable in the denominator. So it is not a monomial if you have a variable in your denominator. So those are some examples of monomials. We're going to look at simplifying expressions. I have r to the 4th and negative 12 r to the 7th. So here we're going to use that multiplication rule where we add. So I have negative 12 r4 plus 7. So that will give me negative 12 r to the 11. Moving over to B, we have 6cd to the 5th, 5c5, a12. Anytime you don't have an exponent like here with this c, you kind of have the imaginary exponent 1. So I'm going to write that in. And now we're going to multiply. 6 and 5 are two constants, will be multiplied. I put those out in the front. And we're going to follow that multiplication property where we add. So I have C1 and C5, and then I have D5. I think this is supposed to be another D. Sorry, D5 and D12. So those should both be D. So we are adding our exponents for C and our exponents for D. So 6 times 5 is 30. 1 plus 5 is going to give us C to the 6th. And 5 plus 12 is going to give us D to the 17th. That's as small as we can get. C and D are different bases, so we can't combine any further from there. All right, now we're looking at a couple of powers of powers rules and how do we combine this. So we have a lot of things going on. I have 2 cubed, cubed, squared. We're going to start from the furthest inside and work our way out. So I would have 2 cubed in here. And that multiplication rule we follow would be 2 cubed times the cube again, so 3 times 3. So that would give me 2 to the 9th squared. And we follow that rule again. 2 to the 9th times by 2. So I'm going to have 2 to the 18th. And I can put this into a calculator and solve it.